Yeah. So, good evening, everybody. So, we'll start today. I think today will be the last session on general organic chemistry. Before I start, I would like to tell you something. Give some, please, whoever is attending the class, please give your feedback. Okay. So, we just got very few feedbacks. So, to improve further or to clear your doubts, so all of you, please give your feedback. Okay. Then the next one is many of you had asked for thermodynamics and equilibrium. Okay, so please give your choice, depending on what you want. I'll continue with the other classes also. Okay, so please let me know whether you need thermodynamics. I think that you will get a message in the WhatsApp group. So give your choice there whether you want thermodynamics or equilibrium. And only when you give your feedback, I can start with the next topic. Okay, I hope it's clear. So now let's move on to the next topic. So today's class I'm going to teach you see, first I will start with mesomeric effect. Mesomeric effect is nothing but resonance effect. See, many of you had asked like me what is mesomeric effect, what is the difference? Many of you got confused. Okay, it's nothing but your resonance. Okay, I'll just tell you what is the difference. The same thing, plus R or minus R effect and all that. The only difference is if it is resonance alone, you'll have only carbon. Okay, carbon, something attached, like if in a benzene ring, if a CH3 group is attached, okay, carbon, hydrogen. So such groups will show pure resonance. Okay, and if a element like nitrogen or oxygen, something like that, it is attached. Okay, we will call it as mesomeric effect. Okay, so there's not much difference. Okay, so let me just proceed. I'll just spend some few minutes on mesomeric effect. Okay, so now it's nothing but, as I told you, it's nothing but resonance. Okay, only a slight difference. Okay, so let me just tell you. Okay, let me take an example of this compound CH double bond CH OH. Okay, I think the balance is satisfied. Okay, then I'll tell you something like this: CH2 double bond CH single bond CH double bond CH2. Okay, then I have another compound CH2 double bond CH CH double bond CH single bond NO2. NO2, I can write it like this. Okay, so these are the three things. See, the first one, okay, you don't have any electron withdrawing group or electron donating group. Okay, it's just purely only carbon and hydrogen. Okay, so this one will show pure resonance. Only it's the name what we use, there's not much difference. Okay, pure resonance. So when you have a OH group, what will happen? You see here also pi, sigma, and a long tail. Okay, so now this one, how will this resonance move? You know, this one will move here, this one will move here. Sorry, not here. It will move here, then it will move here. It's so on. Okay. So now, what is happening here in the second example? A OH group is attached. Okay. So this one, this group is electron donating group. Okay, and electron donation is happening through resonance. Through resonance. Okay, and such when you have an electron donating group, I have told you as plus R effect. This is also same thing, but as I told you, we just give a different name. So this is called your plus N effect. Okay, plus mesomeric effect. Now here, if you see here, you know carbon, it is attached to nitrogen, and you have this one attached to oxygen, which is more electronegative. So now how will the resonance take place? This will happen like this. Okay, this is how the resonance will take place. Now, what is this NO2 group? This NO2 group is electron withdrawing group. Okay, and resonance is happening because of the electron withdrawing group. So, we call this as minus M effect. So, plus M effect and minus M effect. That's only difference between this thing. I have already told you which one will show ortho para directing group. We have seen that plus R will show orthopara directing group, and minus R will show meta directing group. So this, like if the carbon here, it is attached to a different atom, we call it as a mesomeric effect. If it's, as I told you here, it will be pure resonance. Okay. So now one point I want to mention here is all mesomeric effect are resonance effect. Okay, but all resonance are not mesomeric effect. So this is the difference between mesomeric. So now you can make out, okay? As I told you, not much difference, okay? So now you have already told you what are the electron withdrawing groups, what are the electron donating groups, all that we have done already, okay? So now let me just, I'll just give you one problem with respect to this, okay? Arrange this thing in order of, take down the question, arrange in order of decreasing electron density in benzene ring. Okay, so now see here, I've given one. I have taken the same example, what I told you, that is, this is called phenol. I think you all know this. Then you have a compound like this, cyanobenzene, C triple bond N, and you have C just benzene. So what I have asked, decreasing electron density. Now you can see, like, what will this show? We have studied as resonance, but to be more specific, we'll call this as mesomeric effect, and this will show plus M effect, okay? Because electron donation will happen and it will go to the orthopara position, okay? Here, this one will show, this one will pull, nitrogen will pull, so electron withdrawing group. So you'll have minus M effect, and this will be no effect. Now, what will be the order? Which one will have more electron density? A. Then it will be, because minus M, because it will pull the electrons away. So that will take the last position. So then it will be C. Then, so this is the order. Okay, I hope it's clear for you. Now, I just want to tell you some exceptions on this, which I didn't discuss last time. Okay, so now let me give you some compounds like this. See, the more examples you work out, then only it will be clear. H, then you have like this. This is called NH2 group. It is also called aniline. NH2, you have one electron pair. Then you have so now, whenever we tell about the stability, or we know that more the resonance structure, more stable it is. Okay. So now let us see, in these three compounds, what are the effects which can take place. Okay. So now you know this electron can enter the benzene ring. So it will also show, plus M effect. Now you know it is attached, because you see here it is also attached to this thing. So this part, carbon and oxygen, we know that oxygen is more electronegative than carbon. Then what do we say? We call this effect is also as minus I effect. Okay, so here we know that carbon when it attached to the oxygen, so that part it will also show minus I effect. Now, which is dominating? Always plus M will be dominating. So on the whole, the compound will show plus M effect. You will not consider the minus I effect. So now in the second case, we know that it is again this one will enter the electron. So here we know that this is again will show plus M effect. Okay, and this carbon is attached to nitrogen. Okay, so then it will be nitrogen is more electronegative, and this will also show minus effect. As I told you, this also plus M will dominate the minus I effect. Okay, so same thing here also. So please remember that plus M and minus I effect are there. It will be the plus M because we have to talk about the stability next. So always the plus M will dominate the thing. And this, as I told you, it's full of chemistry, is full of exceptions. So let me just tell you an exception here. Okay, exception is your halogen. When the benzene ring is attached to a halogen, let us take fluorine. Okay, so here you have again 6 lone pairs. Okay, so here also what will happen? Electron will enter the benzene ring, so it will show plus M effect. Then we know fluorine is more electronegative than carbon, so it will also show minus I effect. Please remember the exception is in case of halogens, when the benzene ring is attached to the halogen, the minus I will dominate the plus M. See, chemistry is full of exceptions, and exceptions are more important in chemistry because they'll catch you. Fine. So this is the thing. So now let's do a question based on this. Okay, I hope. With all these concepts, let's do a question. The question is, which among the following will have more electron density in the benzene ring? Okay, so now let me give the options. I've already done some of them. Let me take phenol. Then let me take, this is your B, where I have Cl. Then C I have NO2. Okay, so now here first we will see, okay, what are the effects. Now we know that this one electron, this thing will enter, so it will also show plus M effect and it will also show minus I effect, right? Now this one, as I told you, halogen means it will show minus M will dominate. Okay, so let's only write the one which is taking the command. So minus I effect. Here you see electron CH, it's attached to CH3. So what is that CH3? I've already told you it is electron donating group. Okay, so this one will show plus I effect. Okay, and the last one, what is NO2? I told you it's an electron withdrawing group. It will show minus IM effect and it will also show minus I effect. Okay, so based on this rule, what I told you, which is more electron, as I told you, the resonance will always take the command. So now we know A will have more electron density. Okay, that is very clear. Now among B, C, and D, we know after plus M it is plus I, so it will be C. Okay, then it will be we know that it is not it's just an exception, but it doesn't have so much of minus I effect, right? So now here this will be, then it will be. So this is the order of the electron density. Okay, with respect to the previous concept, I've given you some example. Okay, I hope it is clear for you, the mesomeric effect. Now let's go on to, I'll give you just one question for you to try because I've done so many. Let me see whether you people can do it. Take down this question. Now I want the decreasing order of electrophilic substitution. See, they can ask you in different forms. You know what is, I have already told you what's a nucleophilic substitution, electrophilic substitution. So now here you have to arrange in the decreasing order. Please read the question carefully. Order of electrophilic substitution. So electrophilic substitution means an electrophile will come and attack the benzene ring. Okay, if the electrophile has to come and attack the benzene ring has to have more electron density. So I've explained the question also. So now Please give the order. I have given a carbanion here. An aldehyde group. This is called benzaldehyde. Yeah. Can you all try? Let me see. Aditya, I think you got confused. The first choice was right. Anirudh, check. The first two are right. Check, check. Harikeshav, check. Ashwin, check. Anirudh, you have made a small mistake. Check. Saishwaran, check. Aditya, yes, you got it right first. Your first choice was right. Bhavanidhi, first one is right. Second one, you made a mistake. Okay. No, I think. Anyway, let me do it for you. Okay. So here, first, please try to write which one will dominate what. Okay. So I told you in the first one, a negative charge is there. Okay. That is has more this thing, more than the lone pair, you have a negative charge. Okay. So it will quickly enter. As I told you, the charge on the atom, it's very unstable. So it will immediately enter the ring. Okay. So now this one will show plus M effect. As I told you, we will write only the one which is like the major one. Okay. Now this one, oxygen is more electronegative. The CHO group is an electron withdrawing group. So this one will show minus N effect. Okay. Now I told you halogen. This is a exception. As I told you, this one they will take the minus I effect more than the plus M. It will show plus M, but it will always take the minus M. And here we know this one will also enter the ring. This lone pair will enter. Now you see the A and D, okay, see the negative charge is there, so it will undergo more resonance because as I told you, the charge on the atom is very unstable, so it will quickly enter the ring, okay, so most of you got it right, so it will be A. Now you know the last one, that's electron donating group, so plus M effect, so it will be B. Now between C and B, as I told you, C will have more effect because it also shows plus M effect, but I told you it will take over, the minus I will be more prominent. So because when you compare to minus M, this one will be more. So this will be C and this will be. Okay, so this is the order. Right, I hope it's clear for you now. Okay, a quick question now. Fine. Another one, okay? Though I have not told you, but you have to guess this. Which is more, which one will have higher electron density, or which one will undergo more electrophilic substitution, anything you can take. Let me take it as A, B, now you tell me. I think you all know about the electronegative property. Now tell me. Now tell me what is the order, which is more? Here also this. Aditya, check. See, halogens are exception, but check what is the effect there. I told you the resonance effect, like mesomeric effect, will always take the lead. Bhavanidhi, check. Like, I have to see. I haven't told you, but I wanted you people to check. Fluorine, yes, Dhruv. As fluorine is more electronegative. Now tell me which one can donate electron easily. Now give the order. Arjit, yes, no, Arjit is wrong. Yeah, I think most of you got confused here. That's why I gave you this question. Okay, so now here we all know it's very clear from this that this one will have plus M effect. We'll have both plus M and minus I effect. As I told you, plus M effect only will take the lead. Now here this also will show plus M and minus I, but this one will take the lead. Okay, and here also it is plus M and minus I. So in this case, okay, which is more electronegative, which has more electron density, which can pull, okay, and that can donate more electronegative, can give more electrons. So in that case, you can take fluorine is more electronegative. Okay, so here the answer would be A. This is very clear. Then B. Okay, more electronegative atom will take, like we can, electronegative means it can hold the electrons more, and that can obviously enter the ring more. Okay, so A, B, and C is the list. Okay, I hope it's clear for you. Okay, so with this, because why I wanted to tell you this is like, we'll be doing the next topic, that is carbocation. Okay, I hope till here it is clear. Okay, and let me just check. Arjit, yes, okay. Fine, all of you. Okay. Whoever has made mistake, you can correct it. Okay, next we will go to the next one. Okay, that is, we will talk about the intermediates. Okay, what are the intermediates formed? Okay, as I told you, I have mentioned in the syllabus, we'll be talking about carbocation, free radical, then what else, carbanion. Okay, so all these are nothing but the intermediates. Why do we have to study about this carbocation or carbanion or free radicals? Because they are the deciding factor to write the product. So as I told you, this is just your introduction. General organic chemistry is just like an introduction. Only when you know this thing clearly, you can write the products. You can tell this is which is more, which is a major product. And I have told you, in organic chemistry, you have always major product and minor product. Okay, so major product. So depending on these ions only, we can tell which is a major product. Okay, so now let me, not without much delay, let me go into that. Fine. So we'll be studying about the carbocation. Today what I will be teaching you is carbocation. Okay, so now then I'll teach you about the free radical. First, let me tell you what are the intermediates first. Okay, so carbocation can be like, see, like this, CH3 plus. Okay, this is a carbocation. A free radical can be like, I have already told you, CH3 dot. I told you free radical is formed by a homolytic fission. Then you have carbanion. Sorry, carboanion. Okay, which will have a minus charge. Then you have some more things like, carbene and so on. Okay, what you will be studying at least in 11th standard on, which is more important, is your carbocation and free radical. Okay, you will see this in many reactions. So because it's a very huge chapter, lot of concepts are there. So I will teach you only the important ones, that is carbocation and free radical. So after doing carbocation, I will also tell you how rearrangements can happen. So depending on the carbocation stability, the intermediates will undergo rearrangement. So that also I'll be discussing about that. Okay. So these are the things. And why do we study all this? We study all this to decide on the final product. Okay, and these species, the cation or the free radical or the very, very short-lived, immediately they will undergo transition, they will undergo rearrangement. That's why I'll be telling you about the rearrangement also. Okay, so now first let us start with your carbocation. Okay, so now how a carbocation is formed, I have told you, by heterolytic fission. That is, if I have some group X, and we know if X is more electronegative, what will happen? It will pull both the electrons to the X. So you will get, if I remove the X, which is minus, you will get CH3 plus. And this is this will happen as per the heterolytic fission. Okay, down. What are the carbocations? So we have seen, so this is called the methyl carbocation. Then how do you write the ethyl carbocation? This is your ethyl carbocation. Okay, it's again as per your IUPAC you name. So you see here you have CH3, CH2, CH2 plus. This will be your propyl carbocation. And if you have something like this, CH3 and a plus charge, so this is an isopropyl group. So this will be your isopropyl carbocation. Then you have your tertiary butyl. Okay, so this is your, so we call this as a secondary carbocation. This will be your primary carbocation. And how will I write the tertiary carbocation? If there are 3 carbon, if the carbon is attached to 3 carbon, then this carbon will be tertiary carbocation. Okay, so we will just, so the name I have just told you, and we know about these primary, secondary, and so we have another set of carbocations. That is when we have something like this, CH2, CH double bond, CH2. Okay, so here we have a double bond, that is called the allyl group, attached to this carbocation here. Okay, see these 2 carbons have a double bond, and this carbon is attached to a carbon which is having a positive charge. So this is called your allyl carbocation. I hope it is clear for you. When it has a double bond and the next carbon has a CH2 group, such groups are called allyl carbocation, because I want to tell you the difference. If the double bond, imagine there's a double bond and one of the carbon itself is having a positive charge. So such carbocations are called vinyl carbocation. So all these names you have to know, because later, in 12th, you'll find it very difficult when they tell the names. Okay, so all these names you should know. So now let us see little bit some property of carbocations. It will be useful for your competitive exams. So what are the general features? What are the properties of a carbocation? So we know, let me explain with this as an example. That is your methyl carbocation. Okay, so we know that each bond is made up of 2 electrons. I've already told you, covalent bond. Okay, now how many electrons totally does this carbocation have? It has 6 electrons. Okay, so now tell me whether it is an electron deficient or an electron rich compound. Obviously it is electron, because you know your octet rule has to be followed. Okay, so this is a electron. So these carbocations are electron deficient species. Deficient, okay? And so whenever it is electron deficient, what do you call that as? Whenever something has a positive charge, I have already told you, they are called electrophiles. Electrophiles are nothing but electron loving. So it has a positive charge, so it can take up electrons, okay? So now the second property, this is your first property. And the second property, what is hybridization? You see, I've already taken chemical bonding for you. So 1, 2, 3 sigma bond. Okay, so 3 sigma bond means it is sp2 hybridized, because they can ask you such things. Hybridization. What is the shape of sp2 hybridization? We know, I have taught you that it is trigonal planar. I think you can remember, like, BCl3, and I told you it is trigonal planar. See, the structure will be like this, carbon. So there will be 3 hydrogen, which will be like this. Hydrogen. So all these are sp2 hybridized. Okay. Then you have the next p orbital, which is empty, which will have a positive charge. So these 3 will lie in the same plane like this. So that's why it has trigonal planar structure. Okay, and please remember, this is a vacant orbital where it can accept the electrons. Okay, so now, so where do you see such carbocation? Like, you'll be wondering, why do I study all this? So don't worry, next year, the 12th, in the 11th standard, you have only one more chapter. Okay. There also you will be studying about the electrophilic substitution, some reactions which will show you carbocation, and depending on the stability only you have to write the product. So it's very important. Okay, so now you can see these kind of carbocations in substitution reactions. Let me make it 0.3. Substitution reactions, and in substitution you have SN1 and SN2, and we have substitution nucleophilic unimolecular. Then we can see in elimination reaction, that is E1. Then you have addition reaction, electrophilic addition reactions. All these cases, we can see the intermediate will be a carbocation. So they can ask you SN1, SN2, what is the product? So depending on the stability of this carbocation, you have to write the product. Okay, because there are many, if you see the problem, you will see there are so many products possible, but they made only one product, major product. So depending, that is why we study this. Okay, so depending on the stability of the carbocation, you have to write the product. Okay, so now, so whenever there's a carbocation, which one I taught you mesomeric effect, because you have to give the preference, right? Just now I told you the mesomeric effect will take the preference in most of the cases. Okay, so the stability of the carbocation will depend, or the priority order will be, first will be, we call it as either resonance or it is a mesomeric effect. So first this will be given the priority. Next one will be the no bond resonance. What is it, no bond resonance? It's also called hyperconjugation, where I told you about the alpha hydrogens. Okay, more the number of alpha hydrogens, more stable it is. Okay, then the last one will be your inductive effect. Okay, so this is the priority. Okay, so with that, let's do some examples. Let me start with some basic thing. CH3, CH3, CH3. Okay, a carbocation. Then we have CH3, CH3. So this will be your secondary, and this will be your primary and plus charge. So this will have a plus charge. Now, what is the order? Okay, first let us see what it will take. So we know that there's no resonance here. Okay, so you have only in the hyperconjugation and indirect effect. So based on both of this, the priority order will be this one will be greater, this one and this one. Okay, so this is your tertiary carbocation. This carbon is secondary. This is primary ethyl carbocation. This will be primary methyl carbocation. Okay, so now if you see as per hyperconjugation, let's see about the hyperconjugation. So hyperconjugation is no bond refusal, and how many alpha hydrogens are there? You see 3 plus 3 plus 3, so it will be 9 alpha hydrogen. Okay, here it is 3 plus 3, 6 alpha. Here it is 3 alpha, and here there is 0 alpha. Right, and this is your hyperconjugation. Let me put it as Hc. And even as per your inductive effect, we know what is inductive effect? Electron donating group. Okay, the plus charge is very unstable. As I told you, all these charge carrying compounds are very unstable. So the plus charge has to be balanced. So there are 3 electron donating groups. Here there are 2 electron donating. Here there is only 1 electron. Here there is no. So as per both, that is the inductive plus I effect and hyperconjugation, this is your order. Let me make it as A, B, C, D. So the order will be A greater than B greater than C greater than. This is your order. Okay. Now let us take one more question here. This is, I've just told you, I will not include the resonance. Let me use a resonance kind of question. So let us take a benzene ring. Not one, let us take 3. This carbon is attached to. So this is again like a tertiary carbon. Okay, positive. Then you have 2 benzene ring. Okay, so here what we will talk about resonance. So to be more clear, let me put these bonds so that it will be clear. I'll just add for 1. I think you can add it. Okay. So if you see here, how many resonance structures are possible? You know, see each ring will have 3 resonating structures. Okay, and along with this first one, this one. Okay. So totally, you know how the electrons will be shifted. See here. This one will go here, this one will go here, okay, and so on. So each ring 3. So okay, so 3 plus 3 plus 3, 9, and this structure. So totally there will be 10 resonating structures. Here there will be 3 plus 3 plus 1, so 7 resonating structures. Here it will be 3 plus 1, so 4 resonating structures. Okay, we know, I have told you that the more the resonating structures, more stable it is. Okay, so now as per this, we know that this will be more stable than the next. Okay, now let me take another example. I'll give you more details because, as I told you, this is very important. See, they can give this one as also phenyl group. Okay, so they can PH3C plus. They don't have to put the ring always, so they can say the phenyl group, the benzene ring attached to carbon is called a phenyl group. So this is the benzylic carbocation, 3 phenyl ring. Then here it will be 2 CH plus, and this will be PHCH2 plus. Okay, so they can also give you like this. So you can write like this. Okay, so now let me go to the next one. Okay. So tell me which is more stable among these two. Which is the most stable carbocation? Can anyone think about it? A and B. Let me mark it as A and B. Think of the effects. I've given the priority order. Let me see. Anybody can try? Yes, Nurul is right. If you could write what is dominating, that also will be good. Yeah, Saishwaran is right. Anirudh, check. Varnika is right. Yes, Nityashri is right. Akhila is right. Good, good. Fine. Most of you got it right. Okay. Good. Arjit, B will be dominating. Yes. Yes, yes. Tanuv, that's what I wanted. Yes, Nurul is right. Fine. Okay. So as I told you, this one will be, there will be a resonance here. So what resonance electron donating? Plus M effect. Okay. That also be conjugation. Here, what is the thing? Here it will be two CH3 groups. What is the effect here? It is the hyperconjugation. So as per hyperconjugation, we have 6 alpha. So see, this part is the same. This part is the same. So let us consider only this part. Okay. This part, this will have minus plus M effect. Here, this will be 3 alpha hydrogen. Okay. So these two, if you consider, you know the resonance effect will be more. So B will be greater than A. Okay. So now another one more. Let's do. So today I'll give you more practice only on this because as I told you, it's very important. A, B. Yes. Try. Yes, resonance effect. Otherwise, yes, resonance effect always will dominate the hyperconjugation. So I think there only the answer lies. Yes, Adarva, tell me the answer. Bhavanidhi is check. Check Bhavanidhi. What are the effects? Yes, Tanuf is right. Yashraj is right. Sriram Madurantakam. Yes, right. Aditya is right. Good, good, good. Tanuf is right. Okay. See here, as I told you, first think of the resonance effect. Okay. So we know pi, sigma, and a plus charge. When there's a pi, sigma, plus charge, you know it is resonance effect. And what kind of a resonance here? It is your plus M effect. Okay, there's conjugation, so there's a plus M effect. Okay. Now here, what is that? Here there's no conjugation, there's only, what are these? They are electron donating groups. The carbocation is attached to the CH2 group, which says, so what effect is this? So it is plus I effect. Now, which is more dominating? The resonance. So A will be greater than B. Okay, so check for resonance. I told you resonance in detail. If you not understood, just see the video again. Like, maybe you would have missed something. Just check that. Okay. Now, here, I think with that concept, let me give you one more question. Yeah, tell me which one, A or B. Yes, Harikeshav is right. Yashraj, check what are the effects. I told you resonance will take over the plus I effect. Varnika, check. Why? How? B. The first one will show what? Why? Most of you got it right, wrong. See, the second one will show the plus I effect, hyperconjugation and plus I effect. What's the second one? The first one. Yeah. Yes, Nurul is right. B will not show, Tanuf, B will not show resonance. Yeah, Sneha is right. Yuti is right. How is there resonance in A? Wait, I'll show you. Look here. Sigma pi. Okay, so you have. Yes, where did I think I made a mistake. CH. Sorry. There's already. Okay. There's already 4 bonds here. So this one will have a positive charge. Okay, fine. I think I made a mistake. Okay. So see, there are already 4 bonds, so that cannot have, okay, only which is devoid can have. So, okay. So now in this, I hope now you can get it. So pi, sigma, and positive charge. So here it will be resonance. Okay. Here, look here, I am using the word resonance. Why? There is no electron withdrawing group or electron donating group. So I will be using resonance effect. Okay. So here, if you see, both the sides plus psi effect, both are electron donating. So plus psi effect. And as per hyperconjugation also, it will have 6 alpha hydrogen. Okay. Even then, A will be greater than. Okay. Now, so seeing all these things, as I told you, as I have given you all the order, please try to remember that if you're going for competitive exams, okay? So now the order would be, just with this order, you can write the product. I just gave you these examples for you to understand. Stability order of carbocation. So note down the order. This, if you find this one, this will be more stable, okay? Then you have pH2 CH plus, then you have here I will not write pH and CH2, okay? Here it will be CH3 C plus. So please see this, then it will be pH CH2. So what you have to remember is, don't write pH. So here there is a difference. See here, these two. Okay. So this is your tertiary carbocation. Here will be more stable. Okay. When there are 3 carbons. Earlier I told you 2 carbons. Okay. But here secondary. But here tertiary. This one is more stable than this. Okay. So just whatever you have to remember, I told you. Then you have which one will be this? This will be, next one will be CH2 plus CH double bond CH2, then it will be plus, then it will be so ether and methyl. So this is your order. Okay, I hope it's clear for you. Okay, please remember, whatever order I give, you have to remember. Otherwise, see, you can't remember every time all these things. You can't apply, okay? There will be some deviations. Though I told you so many examples you see here, you should not write those. It will undergo resonance here. This will take the next priority than this. Okay, so you have to remember that. So now let me go to the next question. Yeah, so based on this, let's do some questions. A, so just see the thing, okay? So you have 3 things. So you can see the first one, second one, and third. So you know, see here, tertiary carbocation is more stable. So order would be first B. Okay. Then between the allylic and A and C, you see here, allylic is taking the lead now. So it will be A, then C. Okay. I hope you got it now. Let us do a competitive questions. I will not help you. You try, then I will help. This is a JEE question. see. Can you all try this? Because since I've given you the complete details about the carbocation stability, I think you can now just try and get it. You'll get some confidence if you do this question. Saishwaran is correct. Adarva check. Varnika check. Yes, Adarva is right now. Yes, now Anika. Now all of you got it right. Good, very good. Aditya is right. All of you try. See, even if it is wrong, please try. Only then you will get it. Yes, Akila is right. Tanuv, check. Yeah, Sriram is correct now. Sneha is correct. Right. Yes, good. I think you all got it. See, by doing problems, you'll get some confidence. So here we know what is the effect here. We know this is resonance because there's no group, only carbon. Okay. Now, what is this now here? You can write either plus psi effect, or you can also have first which one I will do? I will do hyperconjugation. You see here to this carbon attached. So how many alpha hydrogen? There are 2 alpha hydrogens. So both hyperconjugation and plus psi effect is there. Here again, the resonance is there. Okay, so which has more resonance? It is ring. Okay, it will go around the ring now. Charge will go on. So more resonating structure in C. So C will be more because you can write more resonating structures. Say. Okay, then it will be obviously next resonance is the first one A and last one is B. Okay, so most of you got it right. Very good. If in case you have made some small mistakes, please correct it. Okay, here I have to tell you something. Some exceptions. I think chemistry you'll be tired of exceptions. Okay. So another question. Let's do one more thing. Here there's a CH3 group. Otherwise, they'll just give you a line. So that means it's a CH3 group. Okay. So A. So let me put the positive charge here. Let me put the positive charge here. Yeah. So can you get it? Okay, so what is first? Let me tell you. The first one is pi sigma positive. So what is the effect here? As I told you, there is no all are C and H. So what will I write? I will write as a resonance group. Okay. I hope now you got the difference between resonance and isomer. Also, it will also show plus psi effect, right? See here, there's a CH3 group here. Okay, this will give you electron donating. Okay, so this will also show your plus psi effect. Okay, first write that, then only you will get it correct. Okay, here and one more thing, it is a look here. This positive charge. See here, let me write it here. It's a tertiary carbocation. You can see 3 carbon attached to there. Okay. So now here it is, there are 2 carbon attached to the thing, that is a secondary thing. Okay. So now here, obviously there will be pi sigma positive charge, there will be resonance. And here also it will show you plus psi effect. Okay. Here what it will show, it will not show resonance. It's not all a sigma and positive charge, it will show only plus psi effect. See, once you make this clear, then it's easy. Now I have already told you tertiary is more stable. Okay. These first A and B are same. So this will be greater physics. This is the order. Okay. Now, one good thing what you have to know is, like, it's just out of the box. Like, suddenly something you'll be thinking, I'm telling you. This you should know, and I've seen like many people, many question paper has this question, okay, in the practice session. There's one exception where a compound like this, what is the name of this? Okay, this is methyl, what is this? Cyclopropyl. Okay, so cyclopropyl. There's a CH2 plus charge, methyl carbocation. This particular compound has a very high stability. That is, we can call it as exceptionally stable. You don't have to remember the thing details and all, because if I teach that again, this is a big thing. Okay, this is because we call this thing like, as some with respect to hybridization, and so many difficult concepts are there. As I told you, if I teach this again, 1/2 an hour will go. Just remember, because for your level, this is more than enough. This particular cyclopropyl methyl carbocation has exceptional stability. Okay, so where will you add this in the order? When I put this here, look here, the order, just add it here. Okay, so add that here. I will give you some more. So all that you added before that. Okay, so now I'll give you, among these cyclopropyl carbocations, there can be 3 chances. One is this, the other one is, sorry, I'm very poor in drawing. So this is your cyclopropyl methyl carbocation. Among this one, there are 3 rings here. So this will be tertiary, this will be secondary, and primary. So this will, so all these 3 try to add before that. Not many questions are asked. They have asked you only with this as far as I know. But please remember, this has to be before the stability order of what I have given you. Okay. So now, okay. So let's do one more question on this. This is also a competitive question. One, 2, 3, 4. This is also a JE question. Can you all try this? Which one will be more stable? Yeah. So here, oxygen will have lone pair. So I'm just giving you the complete picture. I have written all the carbocations. Okay, fine. Now you can try. Yes, Aditya, got it right. Very good. Saishwaran, very good. See, I think now you will have some confidence of taking up the JE. Yes, Mukhil is right. Ashwin is right. Oh my God, all are right. Very good. Jyoti, Varnika, good. Atharva, check. Atharva Desai, please check. Check for the resonance. Nitishri is right. Sneha is right. Nobody from one batch, one more batch, nobody is answering. Yes, Atharva Desai is right. Arjis is right. Good, good. Yes, Arjit, you are right. Good. Ashwin, just write what are the effects. Okay, what plus I or plus M, water. Only that effect if you write. Yes, Tanuf is right. Only when if you write the effect, that's more than enough. Okay, see here. First, let's see the carbocation, whether it's primary, secondary, or tertiary. Okay, so let me write that. This, it is attached to, see here. It is, this carbon is attached to one carbon here, other carbon, because other one is attached to oxygen. So this will be a secondary carbocation. Okay. Here we know that it is attached to one carbon here and oxygen. So this will be a primary carbocation. Okay. Here again there are two carbons. This will be secondary and this will be here primary. So first let's make this mark. Okay. Now next one. Can it undergo resonance? This one? Yes, it can undergo resonance. Okay. So now this can, I can call it as, because it's electron donating, and let me put it as resonance. Here also it can undergo resonance. So R effect. Okay. Now here what can it be? Like, there's no group there. Okay. So this one can undergo, look here, it can go plus I effect from here, plus I effect from here. So it can have two plus I effects, two plus I effect. Now here it can have only one plus I effect. So this itself shows. And we know secondary is more stable. So that's all. Once you write this, it's very clear. Okay, so one will be more stable because secondary resonance, then it will be primary resonance. Okay, then it will be two inductive effect or one inductive, two inductive effect in second one, then this fourth. That's all. Okay. Now, another one more question. See, I'm making you do this is because next chapter you will be studying about the stability. You will have to write the product with respect to the carbocation. I have a concept to tell you here. Okay. 1, 2, 3. Can you try? Let me just see, then I'll teach you the concept. It's okay, Adarva. Adarva is right. Now, Sneha, check. Okay, I'll tell you about the concept here. I think many of you haven't got it. Let me tell you this. See here, always, like, there's a pi bond, okay, and a positive charge, okay. So now you see here, there are two pi bonds. There are one pi bond, okay. So now please remember the positive charge on a pi bond will lead to instability. Okay, but a negative charge on a pi bond will give you stability. Okay, so just with this point, you can arrive at the conclusion. Okay, this is very important. Now, you have another thing you'll be studying again in hydrocarbons chapter also, the percentage S character. We know here what is the hybridization, 2 plus 3. Okay, that on the carbocation it is sp3 hybridized. Here 1, 2. So it will be 3. 1, 2, 3. Okay, so it will be sp2 hybridized. 1, 2. Okay, and this will be, that is, you have to check with this. Then here you have only S and P. This one will have SP hybridized. Please remember which one I am telling. Okay, you have to not with the ion, like carbocation, the next carbon. Okay, so it's sp3, sp2 thing. So we know which is what's the highest, S character. We know this one will have more S character, 50% S character we have. Okay, so you should know the percentage S character. We know from that sp will be higher than sp2, greater than sp3. Okay, so what you have to remember is more the percentage of S character, more will it be its electronegativity. Electronegativity will be more. Okay, so now imagine when the last one, okay, more S character, more electronegativity. So what will happen? It will make it destabilize the whole thing, because as I told you, we can tell with respect to the number of pi bonds also. So A will be greater than B and C. So it cannot be electronegative. More percentage means more electronegative. It cannot be electronegative. Okay, as I told you, a positive charge on that particular pi bond will lead to instability. So please remember this. Okay. So now let's do some more questions. Let me see. Let's do a JE question and a NEET question. Then we'll stop with this. Anyway, let's do a NEET question now. Yeah. Can you try first, depending on the electron withdrawing group or whatever? Yeah. Can you just try? Then I can. Let me make this as 1, 2, 3, and 4. Many of you have made the same mistake. Just because OCH3 is there, don't think that is more. Tanuf is right. But no, Tanuf, last two are wrong. Harikeshav is right. Anirudh Bhandarkar is right. Arjit is right. Sneha is right. Now Tanuf is right. Okay. See here, I'll just tell you. Here we have, see very clear, the first two we have both the plus M effect and minus I effect. Okay, because carbon is attached to oxygen. We have to see this resonance also. Okay, so now here also you have plus M and minus I effect. Okay, and here you have, what are the effects you have? Both CCH3 is electron donating group. So you know that see here you can tell about, because once you see this, because all the top one is the same. Okay, here when you see only the bottom part, here it will have both hyperconjugation and it will also have plus psi effect. Okay, and I told you plus psi will hyperconjugation will take it more. Okay, and this one I would say there's no effect. Because the bottom we are considering, because the top one all are same, all the carbocations. Okay, so now here when I take OH and CH3, you can check the resonance. Okay, as I told you, I have given you these details before. So OH will be more, so it will be not A, 1 here. The first one will be more. Okay, OH. Okay, I've given you this order. You can check that. I think today I didn't tell you. Then it will be 2. Okay, and we know we have an electron donating group. Okay, so plus is there, so electron donating group, so 3 will be more stable. Oh, I think I have to write it as per this. 1 greater than 2 greater than 3 greater than 4. Okay, for everything, when I told you about the resonance and all that, the effect I have told you. Okay, just check. Okay, so now, yeah, there are 2 more things which I have to tell you, because each example there will be some exceptions. Let me do this now. The plus charge is already there. Okay. Okay, can you just check let me know the order, whether you can try this? Let me make it as 1, 2, 3. Harikesh, check both. See, I'll give you a clue. If you have the plus psi effect and hyperconjugation effect, the hyperconjugation effect will take the priority. So now you please change your answers, all of you, if you've got something wrong. Yeah, now Aditya is right. Aditya S. Now Tanuf is right. Yeah, Arjit is right now. See here, I've told you that top part, all are carbocations now. You have to see only with that part, okay, whatever is in the bottom, only there you have to see what are the effects, okay. Now you see here double bond and you have allylic. So, okay, you have, this is electron donating group, it will have a plus psi effect. As per hyperconjugation also, you have 3 alpha hydrogens, okay. Now, because we have to take this alpha hydrogen. Here, you have 2 electron donating group, and you also have, as per alpha hydrogen, you have 1 alpha hydrogen. Okay, see here, double bond and the carbon here. Please remember that if you got here and this. So the alpha hydrogen will be only this carbon. So 1 alpha hydrogen. Okay, here it will be 0 alpha hydrogen. Okay, but it will all this, because see, this one will show plus psi effect. So I think as per the plus psi effect, there are 3 plus psi effect there in this. You people wrote 3 greater than 2. No, which one will take the priority when both hyperconjugation and inductive effect is there? Hyperconjugation will take the priority. So as per that, we will tell that 1 is greater than 2 greater than. Okay, I hope it is clear. Now the last question on inductive, this carbocation. Let's do that. Okay, then we will go to the next topic, rearrangements. So the last question, let's do this. This also I told you in the last class about the resonance. So please check that. Always keep one note for this so that you can go back and check. I've told you about this resonance here, okay? Yeah. Let me put it as 1 or 1, 2, 3. So where is the electron density? See, you have to make the carbocation more stable, okay? So you have, as I told you, whenever there's a charge, only when there's an electron donating group, okay, it can be more stable, okay? Depending on that, can you just try this? Lakshmi, Pradyumna, check. First one is right. No Tanuf. No Saishwaran. Check for the orthopara effect. See, it's an electron withdrawing group. Yes. Harikeshav is right. Very good. Aditya S is right now. Yes, Arijit, you're right. Yeah, now all of you got it right. So every time I have to give you hints. So please remember, I will not be there to help you in exams. Okay. So now you know here it's an electron withdrawing group. Okay, NO2. If NO2 is attached to the carbon, what will you call it as minus M effect? And it will also give you minus I effect. Why? Because this is a carbon which is less electronegative than nitrogen. So we have to consider both. Okay. Now here also, here there's no minus M effect because in the meta position we don't have that. Okay, so there is no minus M effect, there's only minus I effect because we know it's only only in the orthopara. So I'll just give you that point, and here also there will be minus ortho position, minus M and minus I effect. So please remember, in meta position, okay, there will be no mesomeric effect. So we have 1 and 3 which are out of question now because both of those are showing. So now first with that we can say 2 is more. Okay. So we know as per the distance and all that we can say it's in the para position. Okay. So para position will be always more stable. So and that ortho position, it is very close to that positive charge. So it will be 1, then most of you got it right. Very good. Okay. Fine. That's it. So now we will go to the ring expansion and ring contraction. Okay, so we will just take a 3 minutes break. Okay, just 3 minute break. By 7:22, we'll be back. So now we'll continue with so we will apply this carbocation technique. Just a minute. So we'll apply this carbocation technique, okay, for writing the products. So there's another important thing called the ring expansion and ring contraction, okay. So you will see when I'm doing that how important these intermediate carbocations are to write the product, okay. So with that, we'll also do some examples, right? So let me write it. Ring expansion and ring contraction. So sometimes you'll see that there's no problem, there's no answer, where you have to do the substitution. Okay, so it would have undergone some positive species will undergo either, imagine a 5-membered ring can become a 6-membered ring, okay, or a 4-membered ring can become a 3-membered ring, okay. So the conditions for ring expansion are, okay, a C4, there are 4 carbon, cyclobutane kind of thing, can become C5. This is one condition, okay, and a C5 can become C6. In the ring, there will be either 4 will become 5-membered ring, a 5-membered ring can become a 6-membered ring. And in the contraction, there's only one thing, that is a C4 compound can become a C3 compound. So these are the main conditions, okay. Now let us see when a compound can undergo expansion, ring expansion. Okay, so first let us take C4 to C5. Okay, so let us take cyclobutane, a plus charge here. Okay, and when a compound can undergo ring contraction. See here, when the positive species is away from the ring with a group, okay, that will be a CH3 plus group, right? The first one. So that one will undergo always a ring expansion. When the positive species is not in the ring, so such compounds will undergo ring expansion. When the positive species, okay, is on the ring, then it will undergo ring contraction. Okay, so let me show how this first one is undergoing ring expansion. Okay, so let me do step by step. Positive charge. Okay, now we will consider the ring here. Let me number it as 1 and let me number this as 2. Okay, so now see here what will happen if this bond will break. This bond will break. Okay, when this bond breaks, because you have already a positive species here, this will take a negative charge and this will take a positive charge. Okay, see, I'll show you. This will take a negative, this carbon. When this breaks here, this will take a positive charge, that carbon. Now what will happen? The minus and the outside positive charge will combine. So what will happen? There will be, so I'll just write the next thing also. Okay, so this has broken, so I'm putting it in the form of dots. Okay, then you have 1 here and 2 here. Okay, with a positive charge, and as I told you, this one will be positive. Okay, sorry, this will be negative. When this will be negative, what will be this one? This will be positive. Right? So now what will happen? This negative and this positive will join. Okay, so as a result, and the positive charge has moved to the first position. From position 2, it has come to position 1. So you will have a structure like this with a positive charge on carbon 1. Okay, so we can write this one. It looks very odd, so we will make it to our convenience. It's a 5-membered ring. We will make it like this. So this is how a ring expansion. So whenever there's a chance like this, okay, the product, you how to do a ring expansion. Okay, the product, if you see, sometimes you'll see in the product there's nothing like this. Okay, so please see to it what kind of a ring it is and see whether it can undergo the expansion. Now let us see about the another one. We will also see. So I've showed you the 4-membered ring undergoing a 5-membered ring. Okay, so this is 4 carbon to 5 carbon. Okay, so now let us see a 5 to 6. I told you another possibility for 5. So 5 carbon will be like this. So if you see any basic book will have this. Okay. So now let me write it as, let me put this a positive. So when the positive charge is outside, please remember it will undergo expansion. So let me make this as 1 and this is 2. Okay. So as I told you, now it will break here and this will be positive charge and this will be negative charge. And what will happen? You have like this. So this, so let me just write it as dot dot dot. This will be like this. Okay. So I told you, so this one, the positive charge will move here and the plus and minus will combine here. Okay. So this is your 2. So now this can be written as, now this becomes 6-membered ring. So it will become, so as if you write it just like that, you will write it like this. Okay, so as I told you, this will, we don't have such things. We all usually write it like this. This is a 6-membered ring with a positive charge. So these are the things, how, like, how it will undergo ring expansion and ring contraction. Okay, now let us do one more. Okay, you can apply the carbocation technique now here. Okay, a 5-membered ring, a positive charge. Let me make it as 1 and 2. Okay, so I told you the positive charge is away from the ring. Okay, so it will obviously undergo ring expansion and the positive charge will move here. You can see the mechanism. I don't want to write it again. So you will have like this. Like this, right? Then you have one group has got attached, so one more group is left and the positive charge will move here. Okay, so this can be always written as, okay, so just be write it. So we can write a 6-membered ring. Okay, there's a group here, that is this one, and the positive charge of this. Okay, so now what kind of a carbocation it is? You can see here that here it is, this carbocation is attached to one carbon here and the other carbon here. This will be secondary carbocation. Okay, so now you know here there is a methyl group. Let me write the methyl group, and also there will be, to balance a carbon, there will be hydrogen here. Okay, now if given a chance, okay, if it can move, it will go to the most stable state. So this will rearrange itself. That is, this hydrogen will move to this position, this carbon, okay, and the positive charge, this positive charge will move to this position. So we will get something like this, positive charge. Now we can see here, this is a tertiary carbocation. Okay, so what has happened here? There is like 1 2 hydrogen H minus shift, right, on all this. 1 to hydrogen shift. I'll tell you about the shift again. What all can shift, I'll tell you. So this kind of shift, when it can just go one step and make it more stable. See, if I push you inside a swimming pool when you don't know swimming, what will you do? You will just try somehow catch somebody nearby and come and stand near the thing, right? Wherever you can hold somebody, right? Just like that. If it is very close by, obviously you can just go to the most stable state, right? Same way here also, just one shift of the positive charge. If it can happen, if there's a possibility, then one group will move and So now we know, so this will be the product. So this carbocation will be more stable. Carbocation which is more stable than. So this kind of thing also can happen in a ring expansion reaction. Okay. So now I hope it is clear. Okay, then we'll do one question. You can try this. I don't know whether you people, because you have not studied too much of the other chapters. Let me see whether you can try, or I will do it for you. I will do it for you so that, because most of your 11th grade. Okay. Now I have a BR here. Okay. So now let me do a substitution reaction. Okay. I am giving you aqueous AgNO3. Okay. Now we know that, see, aqueous AgNO3, and what will happen now? AgBr will be forming. So the aqueous means you will have H plus and OH minus also. Okay. So I will give you the byproducts. The byproducts are the Br will come out forming AgBr plus NO3 will give you HNO3. So you will have to have, instead of Br, see, H plus is gone, okay, NO3 is gone, and Ag plus is gone. So now you have OH to be attached to the Br. You will study, when you are studying about the substitution reactions, you will know what is getting substituted. Okay. So now, as I given you the byproducts, let us write, first what will happen to this now? This one will give you the Br minus will go away, minus Br minus. Okay, so it has to form a positive charge. So look here how I'm making the positive charge. Okay, so the Br has gone from this one, so this one will have a positive charge. See here, very clear. Okay, so now 5-membered ring and a positive charge outside. What will happen? It will undergo ring expansion. So first, when there's a positive charge, do not put a OH here. Okay, and write the product. No. Okay, so now this will give you a product like this. So as I told you, don't write. I will also tell you which is right and which is wrong here. So this one will undergo rearrangement, giving you a plus charge here. So now this will undergo this thing. So as I told you, it will be a tertiary charge. Okay, tertiary carbon atom, which is more stable. Okay, so now the OH has to come and attack that positive. This is the positive position here. Now the product will be here and the OH will get attached here. Okay, this is basically a CH3 group. Okay, so please do not write if they give you some OH minus substitution. Okay, don't stop it like this. Don't write. This is not the right answer. This will be your right answer because it has undergone ring expansion reaction. I hope the ring expansion, and you have to, why I showed you with respect to carbocation is to check, depending on the stability, it will rearrange itself and will give you the product. Okay. Now, let us see the ring contraction. Now, let's do a reaction with the ring contraction. I told you ring contraction is only one thing, that is C4 to C3. Okay, so I have already told you the mechanism. So, I don't think I told you about the contraction. I told you only about the expansion or positive charge. So when the positive charge is on the ring, it will undergo contraction. Okay, so as soon as you see here, please see here, you will have, it will become a 3-membered ring. Okay, so see, this one will break. Okay, and here it will be a free radical. So it will be like this. So one is breaking, other one is making. Okay, so you will have a positive charge. Okay, so now you will write this one as, now this is the new bond form, that is this one. Okay, then you will have, because the positive charge will obviously move to the next position, it will be, so this is your, okay, so tertiary carbocation, fine. So now we have, this is your intermediate. Now, as I told you, can it, because what is this? This is a primary carbocation. Now, given a chance, it will go to, it can move one. As I told you here, there will be a hydrogen. So it will shift. This positive charge can move here. See here? You can move here to this positive charge. No, sorry. I think I made a mistake. It's correct. I will rewrite it. I think I've already just now told you, right? So we can write it like this. So do you remember the carbocation? Okay, I told you add something. So you can, as I told you, this is the most stable carbocation. Okay, even apart from, I gave you a list of the stability order. Then I told you to add this. As I told you, this is very, very stable. Okay, so it has formed the highly stable carbocation. So this is how the product will be. Okay, so now let us do an example with respect to this. So I've just shown you the mechanism. So let's do a question here. So it will start only with a C4 species. Okay, let me have a Br here. As I told you, when I add aqueous AgNO3. Okay, so let me not do that. Let me not confuse you because you're not studying the reactions. I have to substitute OH minus instead of that Br minus. Okay, let me write it like this. So then what will happen? First step is the Br minus will go away. So what is the carbocation form? The Br minus will go away. You will have a positive charge here. Okay, so now what will happen? Positive charge on the ring, so it will undergo ring contraction, and I told you the most stable species plus charge. Okay, so now this one, add OH minus. Now I'm adding OH minus so that it, so OH minus will go and attach the positive charge, so you will get the product OH. That's all. Very, very simple. Okay, so you can try out. There are some questions with respect to this. Okay, so you can try. Okay, let me just give you some questions now. I'll just try just to be confident that you have understood. Let me give you one question. Okay, and let me see whether you have understood. So I hope you understood the the importance of a carbocation. The question is, write the product of the following reaction. I'll give you the options. You can try. See, organic chemistry will look huge. Okay, the concept will be in just one corner. You have to apply only that. Okay, I have told you aqueous AgNO3 means you have to add, like, OH will be substituted. Okay, so I have given you this. The answers I'll give you. You have to tell me which is the answer. One is like this, OH. The second is just, you can see, eliminate. First, whenever it's a competitive exam, try whether something you can eliminate. Okay, then you can write the product. Let me see which is the correct answer. This is just to test. Tell me which is the right answer. This is your fourth one, sorry. Just tell me one answer, which is right. 1, 2, 3, or 4. Yes, Cherukuri through. Very good. Check, Aditya, Bhavanidhi, check. I told you it will go to the most stable thing, carbocation. I'll just check. Try to form the most stable. If there is a chance, please move the carbocation to the more stable state. Mridula is right. Saishwaran is right. Yes, Aditya, now you are right. Yeah, now everybody is getting it right. Akila is right. Okay. Smruti, Vashisht, very good. See, it's just a practice. Okay, once you get it, then all your answers will be right. Okay, whatever you try for competitive exam will be right. Okay, so let me just tell you the concept here. So first you have the intermediate. Okay, so we know once the Br minus this part goes away, let me write it here itself. When the Br minus goes away, there will be a positive charge here. Okay, so 5-membered ring and a positive charge outside, it will undergo ring expansion. So the ring expansion would look like this. Okay. Let me write it like this. Yeah, a plus charge here. Okay, see the plus charge there is a secondary one. So it can move to this position now here. Okay, tertiary. So it will move and you will get. What will move here? Now there's a methyl group will move. There's no hydrogen there because there is a methyl group here. There's a methyl group here. Here there's no hydrogen. So obviously the methyl group has to move. Okay, so we can write it as 1,2 methyl shift. Okay, so what will happen? You will have a methyl shift here and you will have a positive charge here. Okay, so now that has become a tertiary carbocation now. So now you add the OH here. So you will get the product OH. So let me write it as per that only, CH3 and OH. Okay, this, so your option 3 is right. Okay, I hope it is clear. So this is all about expansion. Okay, now another important concept is, I think we can do only carbocations today. Okay, there's more than it. The free radical is just like this. Okay, so now let's see. We have in the first case we saw there was a hydrogen shift. In the second case we saw a CH3 methyl shift is there. Now which one? When given a chance, imagine if there is a hydrogen and a methyl, and imagine there's a benzene ring there. Now, which one will take the preference? Whether the hydrogen will move, or the methyl group will move, or the phenyl group will move. So, depending on that, we will see the priority. So, we can, as I told you, we have seen a H minus shift. There can be a CH3 minus shift, or there can be a phenyl shift. Phenyl is what? A benzene ring. Okay. So, minus benzene. So any of these shift can happen. So let us see this kind of. So I have already told you. Anyway, let me just quickly tell you about this with one example. CH3, CH2, CH2 plus. Okay. Now, as I told you, this carbocation is primary. So it can move to the next carbon to be more, the isopropyl it can happen. So 1,2 H minus shift can happen, giving you CH3, CH plus. So the product you'll see here, this kind of a reaction in the 12th standard first chapter itself, you'll see. You'll see why is this product formed. Okay, so this is more stable, that is secondary carbocation. So the product, if you react something with some minus group, it will not go on attached to this carbon, it will get attached to this carbon. Okay, so now, so same thing, it is the same thing with free, with the other groups also, methyl shift also. Please remember that these kind of shifting can happen only in carbocations and not in free radicals. Please remember this point. This kind of a shift, Okay, to make it more stable, it can happen only in carbocation and not on free radicals. Okay, so now let us see one more thing with respect to methyl shift. CH2 plus. Okay, so now we know this is primary, and if this positive charge moves to this carbon, it will be tertiary. So what will happen? There will be a methyl shift. So one of these methyl group will move to the carbon. So the product, the carbocation will be CH3, CH3. This methyl group will go on attach here. So you will have CH2 and CH3 and the positive charge will be there. And you know this is a tertiary carbocation which will be more stable. Okay. So now let us see even a phenyl compound. Let us see. pH means it's a benzene ring. pH CH2. Okay, so here what can happen? There can be, so here it will be 1,2 methyl shift, and here it will be 1,2 pH minus. All are minus charge. Okay, CH minus shift. So this will be here. What will be the product? pH C pH CH2 pH. Okay, so this will be your tertiary carbocation, which is most stabilized, like compared to your hydrogen, methyl, and phenyl. This pH, because why pH? Because it is resonance stabilized. So here tertiary carbocation, and you'll also, it will be a benzylic one, that is resonance stabilized. So this will be the most stable carbocation. Okay, so now let us see. Yeah, so now the other question is, as I told you, that let me take CH2 plus. Okay, so now here you have in this carbon, there's a methyl group attached, there's a hydrogen attached. Now the confusion is which one is going to move, whether there will be a 1,2 hydrogen shift or is there going to be a methyl shift. Okay, so now we will write, so we can write anything, a CH3 group can go, as I told you about the stability, the CH3 group can go and it will form a positive charge. So this is again primary and this will be tertiary. Okay, so depending on this, so you will write it like this, because methyl group is more like the electron donating, it will move. So, but that is not the case. Okay, so let us see which one is going to take the preference. So this is called your migratory aptitude. Fine, I think I'll forget English. Okay, so now the electron, now the order is, please note down, because we are not taking CH3 plus, it is going to be CH3 minus which is going to move. So we can write down the electron donating group will have more migratory effect or aptitude or whatever. Okay, so now as per that we will write H minus. When I told you H minus and CH3, which one will move? Okay, so it is not the CH3 plus which is going to move, it is going to be the H minus which will move. So this one, when given a chance, H minus will move. Then it will be the phenyl ring. If all three are there, hydrogen, methyl and phenyl, it will be the phenyl group which is going to move. Then it will be CH3 minus. Okay, so now this is the thing. So now let us write the other order. We know that, one sec. So let us consider, so this is the major thing. Now when I write, this is your first point, let us make it. So now among these methyl groups, okay, hydrogen, if there are 3 carbons and all that, so now the second one will be your, this one will have more migratory group effect, the CH3 minus, which will be greater than the secondary carbanion, CH3 minus CH3. Then it will be CH3, CH2 minus, then it will be CH3 minus. So here you can change it, like, so we can write. So if I put these two together, let's make it one order, migratory, H minus, then it will be pH minus, then it will be tertiary alkyl, then it will be secondary alkyl, because this is tertiary, this is secondary, this is also primary ethyl, this is primary methyl, okay. Then it will be tertiary alkyl, then primary alkyl, then it will be C. So please remember this to write on the problem. All this will be very useful for you for the competitive exams, okay. So now let us see what's going to shift. I hope this thing is very clear for you. So let's take an example. Something like this is it, okay. So now here we have, see here, there's also hydrogen here, right? And what does this mean? That there's a methyl group here, right? Now, which one will move? It is not the methyl, it is the hydrogen which will move. So here what will happen? You will have 1 to H minus shift. Then you will have a positive charge. The hydrogen will move to that position. You will have a positive charge. So tertiary carbocation. Okay, I hope it's clear. Now, let me give you another one. These things can also move further. See, if there's some chance like to move further and to form a more stable one, that is also possible. Okay. So I think, so please bear with me. I'll be taking little more extra because today we have to finish this chapter. Okay, so this is called your extended shifting. Can also happen. Just to make it, as I told you, if I push you in the swimming pool, if somebody is near, you will come there to more stable state. And you can see that, only little more distance I have to swim to go and catch some steel bar or something to be more stable. You will try that also, right? Same way. It's all your, natural process only. So it will try to be more stable. Okay. So this is called your extension shifting. So here it will happen till the shifting can happen till we get the most stable cation, stable product, anything we can write that. Okay. So now let me give an example. CH3 plus. Here obviously only this hydrogen, I told you only 1-2 shift can happen. So this hydrogen can move to this carbon. Okay. So the first step will be 1-2 hydride. It's called hydride. H minus is called a hydride shift. Okay, and directly it will not jump. Okay, it will just go step by step. So first you will get CH3, CH, CH3, CH plus and CH3. Now is it another one possible? Okay, now what happened? This hydrogen can shift to this. Another one more hydrogen, 1-2 hydrate shift can happen because it will be more stable. So here again 1-2 H minus shift can happen. So you will get CH3, C, CH3. The hydrogen has moved to the next carbon, so it will be CH2. Please remember, it will not jump from the just to, it will see in the third, fourth position, there's something where it can be stable. No, it will happen if there is a possibility of doing step by step, only then it is possible. It's just like if you see the whole compound and see, okay, that position is more stable. No, it can happen only if it can happen step by step. Okay. So now this will be more stable. Okay. So now let me do one more. So I don't have time to give you problems. So let us do only the, okay. So if I give next question. So what can happen now? What is the final thing? If I ask you what is the final, let me not go step by step, okay? So this hydrogen can come here. Then this hydrogen can come here, okay? Now, you will have two things in mind, okay? Whether can it be CH, C plus, sorry, CH3, CH2, CH3. Either this can form, or will it move another step, okay? Whether this positive charge can come to this carbon also, that is also possible, right? So you have another chance where you have, it can move, it can form like this. Okay, C plus, C, CH3. So the H will be here, CH2, CH3. Okay, so now I have already told you about the stability of carbon. Now you have to go back to your carbocation. As I told you, the benzylic will be more stable because it can undergo resonance. Okay, so now among this, now which one? This one can undergo resonance. Okay, because the positive charge is on this carbon. Okay, so it can undergo resonance. So this will be, so this will not be the carbocation. This will be this one, which is the most stable. So if you have some minus group coming, it will go. This will be the product, the OH, so, or any minus group will get attached to this carbon and not to the, let me make it as 1 and 2. So the OH minus, imagine if a OH minus is coming, it will go and attach to the carbocation, which is the second one, okay, not the first one. Okay, I hope it is clear for you. This part with this, the carbocation stability and all that is over. So let me just check. There are a lot more for your JEE. I think you can undergo some courses for that. Okay, so let me quickly tell you about, before, because I told you, you will be studying about the carbocation, in the next chapter. And, most chapters will have mostly about the carbocation. And the other one is your free radical, okay? So I'll just quickly tell you the thing. It is just like your carbocation, the free radical thing also. So let me go into it. So how is a free radical formed? I told you, like homolytic fission. Okay, imagine you have CH3 and the X group here. Homolytic, it will break exactly half. So you will get a CH3 free radical plus a free radical. Okay, so now you have same like how I told you carbocation, you have a tertiary carbocation, secondary, primary. Here also you will have tertiary free radical, secondary free radical, primary free radical, ethyl free radical, methyl. Same thing, not much difference. A slight difference. Okay, so that order you can take it down because that's what is more important for you. So stability order. We have stored, I've already told you about the carbocation stability. So this is what will work out for you. Stability of free radicals. So here, so you can see I have already shown you some reaction. What is that reaction? I told you, one mechanism, a substitution where you use sunlight, okay? Methane plus chlorine will give you that, chain initiation, propagation, termination, same way. So such reactions, say you have to know the product, right? So we have to also check the stability of the free radical. So the order is, there will be only little difference. The basic would be tertiary greater than this thing. So you can write the order. One sec. Now, in your 11th standard next chapter, you will study the tertiary free radical is more stable than secondary than primary. This is what you will be studying in your textbook. But for you want to go for a competitive exam, you can please write the order, stability order. It is again just like carbocation, it will be the phenyl, triphenyl carbon free radical, which will be greater than, you can also put instead of C6H5, pH, sorry, this is 3 types, okay? So C6H5 or pH twice. So you can also write it like this, okay? So don't get confused. So here it will be CH which will be greater than C6H5, CH2 free radical. Here there will be slight change you can see there. Okay, when you compare with the carbocation, you can just compare and check. So, sorry, next one will be, let me write it here, CH2 dot CH double bond CH, your allylic free radical. Then comes your, so there will be some difference only in this part. Okay, go back and check. Free radical, then it will be CH3 twice CH free radical, which will be greater than, sorry, CH3 CH2 dot, sorry, which will be greater than the methyl free radical. So only there's a slight change. That's why I wanted to tell you about this. So if there's a chance of movement and all that, like, so you can just try it out. And as I told you one more thing, the free radical carbocation can move, but free radicals will not move. Okay, so that point also please remember and get the product. Okay, I hope it is clear for you. So I hope most of the GOC is over. Some things which is not there, I think you can see some course, or maybe if given a chance, I'll give you. Okay. So now let me just conclude. I hope you all enjoyed the course. Okay. Again, I want to tell you, please, all of you, give your feedbacks. Whoever has attended, please give, because we have not got enough feedbacks. That is very much necessary for us to decide on our improvement, or what can be, like, how you can clear our doubts, we can clear your doubts. And the other thing is, please give a suggestion whether you want thermodynamics or equilibrium, and main condition is only when you give your feedback, okay, I can proceed. Okay, I hope you all enjoyed the course. Okay, thank you. Yeah, thank you all. So please give your feedback.